Hi Ahmed, how are you?
Hey, hello.
Hello, how are you?
All great, great to be here.
Pleasure. How's the day going?
It's going great. It's just the half from Paris. I think it's end of day for you
Yes, it is end of the day for me. Yeah, I've
and
been
end of week.
end of the Actually, this is a perfect time for me to get into these kind of sessions, so I don't have to worry that I have to go somewhere. Another meeting is coming. I know it's not fair for you guys, but yeah, take the opportunity. Take advantage, right?
It's a pleasure. It's a pleasure to be here. So thanks everyone for joining. Good to be here. Um, so quickly I can present myself. I have been a data integration architect at the early part of my career, and then moved to multiple positions, including head of data platforms and more recently to chief information officer. So today I have wrote about data integration in the past, published my book, The Data Integration Guide, published a couple of Udemy courses as well around data integration and AI.
Yeah, it's again pleasure to have you around, Ahmad, and it's again an honor to discuss this topic. This is one of the most interesting topic for me as well because integration is something everybody should be aware of. It has all its own merits, demerits. So no one is better in front. In my point of view, no one is better than you who can explain business as well as technical, as you have written a book on top of it as well. So I think let's jump onto the uh, questionnaires which we need to discuss. So I'll leave the floor to you and I'll keep jumping myself into it as well and asking throwing some challenging and difficult questions to you or here and there. But for the audience, I think let's start with the simple piece, simple, simple point where like what is data integration and what are the different patterns, types. People use different words, so I won't take a lot of time onto it, but I try to put up all these fancy words here that data integration is not simple. There are a lot of things in data integration. We talk about real time, batch, federation, replication, synchronization. All these terms you can see on the screen. These are all relevant and are used whenever we are integrating with a system. System we can integrate as a source system. We can integrate as a target system. So integration is everywhere. Within the pipelines, there are integration, transformations, there are integration. There are a lot of integration areas we all data folks interact with. So I'll go back to the slide. That slide, I'll just put it over there just for the sake of people who want to go back and just refer different areas of integration. So Ahmed, again, pleasure. Floor is all yours. I can go through one by one, but that's not our style, as you all know. You can jump in, you can pick and choose your questions, and floor is all yours. Please,
Yeah.
Ahmed.
Thanks, Mustafa, and it's pleasure to be here as well. And I for the terms that you put in the previous slides of the patterns, that I know a great book called I Am Datapedia wrote by my friend Mustafa.
Thank you.
That is a great book where you can find great definitions of those terms. And I have been honored to participate to the data integration part. There are 300 terms there, and there are a couple where I did proudly participate.
My honor. It's
So,
my honor. You you
yeah,
you agreed to be part of it. Thank you.
thanks. And to start with data integration, I think the very simple problem it tries to solve is you have application A and application B, and you would like to have data flowing from one application to another application. It can be as simple as synchronizing customer data or sending transaction information between one system and another. And when we start looking into the different patterns and we say, okay, now I have this application A and application B, how am I going to do it? Am I going to do it real time? Each time there is a change, I'm sending the information. So that is a specific pattern. Am I going to do it in batch mode, like I'm going to do every night at midnight waiting for an off-peak hour on which I'm going to synchronize both system and send all the data from system A to system B. We are speaking about another pattern like batch and ETL. And then if we start looking into more complex information systems, we are no longer thinking about application E, A, and B. We might be looking into a lot of applications that are in the landscape and how we can make data flow between each of those systems. And then we can have multiple patterns. Some, as I mentioned, can be real time. Some can be asynchronous and in batch mode. And then as we go into more details on how to manage these patterns, we will see new patterns that are arising and that are getting more and more ground today, like, for example, event-driven architecture, where we will wait for an event in a given system to push an information to another system. And then as we move forward with the complexity of systems, we can think of orchestration of integration between systems. And we have tools like ESB, Enterprise Service Bus, that can do that in a great manner as well. Also, depending on the needs and depending on the volume of the data, your pattern can change. You can look at data streaming, for example, when you have a certain volume plus a need for real time or for near real time. And then there are other patterns that might be associated with data integration and might not always be a classic data integration, like data virtualization, for example. And in data virtualization, you are not really moving the data from one system to another. You are creating some logical view that will be seen for example, data analytics or a BI tool. So that's maybe in a quick introduction, some of the examples and some of the patterns related to data integration.
Yeah, thank you, Ahmad. Thanks for elaborating all those difficult terms in such a easy way. Thank you so much for that. I think let's quickly jump onto the real world where we actually use data integration. Our first question, actually, you already just elaborated. The second one is, what is the importance of data integration in business landscape, right? Because normally what happens for a ETL developer, integration is just about open a firewall, create a SQL endpoint, just use a JDBC or ODBC connector, or maybe via an API pull and push mechanism, and that is integration. For business, it's not like that. Business look into many things. Interoperability is one of the key area, right? So they look into a different pattern. For them, business just want a data, right? So data, you cannot end up pulling everything. You have to go, as we always say, for all app system and all other system is always top to bottom. You get the KPIs and then you start integrating, right? So how do you define, how do you take up this one?
Yeah, right. I think data integration is sometimes looked at as a technical brick in an information system, and business might not see a direct need, and it's not always simple to explain this technology to business stakeholders. So it's important to always start from the problem that we are solving and explain that classic point-to-point integration might not be fit for a given reason, or explain as well that given the evolution that we are having in a given information system, we cannot rely on just point-to-point integrations. It will create what we call a spaghetti bowl in terms of flows and integration that you are creating. So first things is have a clear and direct discussion with business that explains what problems we are solving. Then once we are clear on those problems, we need to explain the business value that data integration tool provide. And I think the easiest one that is easily understandable by everyone is improving the go-to-market time, the time to market. And to improve the time to market when you are doing this with data integration tools, say, for example, you are connecting with a Salesforce solution or you are connecting with a given ERP. If you are developing that from scratch, you will need to spend a lot of time to build just the connector, not saying about linking every web service and linking every XML and loading every WSDL file. And if you are using a data integration tool, it comes already with a palette, or it comes already with a pre-built set of connectors that you can use off the shelf. Like you don't need to build anything. You just need to do basically a drag and drop, configure your connection with 3-4 parameters maximum. When we look to solutions that existed 5 and 10 years back, we had just the basic technical connectors, and we needed to do the mapping field by field, etc. As we are moving forward, the data integration tools are becoming more mature in terms of number of connectors. I have seen tools in the market coming with 800, 1000, 1500 connectors. So basically, instantly it gives you that possibility to integrate with a big number of tools. And the other thing is that as we also improve things with artificial intelligence, we start to see patterns in those tools where you have some kind of pre-mapping that is suggested to use, or there is what we call the crowdsourcing mapping, meaning that between some systems that are more or less standard, like you are linking a given ERP to a given standard CRM solution, you are no longer going to do the mapping field by field. You have some pre-mapping that are there, and you just need to add that specific dynamic field that you have added because you have a specific need. And in terms of time to market, this changes things radically from building from scratch to using such tool. And then, of course, there are multiple other things that you gain when you are having such solution. You have the compliance part that comes built in. You have some of the security part that comes built in. You have the logging. You don't need to build everything related to log. There are, of course, things that you need to do, but you can go very fast in implementing this. And this is an undeniable, clearly business benefit that we see. And then, as we build things and we move forward, it is when you see an information system that has been built with point-to-point integrations, like after 10 years, 15 years, or 20 years, it becomes completely impossible to maintain. Like every change is becoming extremely difficult to impact. Whereas when you are having a data integration tool that you implemented initially and continue to build and maintain over time, you will be having more easy. It will be easier for you to make these changes, to swap one system by another, and to make these changes happen over time. So yeah, that's globally maybe a couple of business benefits when it comes to data integration.
Yeah, so actually I can throw a few more questions on this one before we jump into AIPs, right? Because AIPs, they become very sophisticated. And I think we have enough time. We'll go deep dive into AI integration. But before we go into it, right, I really want to, just for the audience, right, I really want to bring in these three terms: batch processing, real time, and streaming. Normally what happens, people mix up real time and streaming, right? Normally there is no real time thing, there is near real time. Either it is batch, either it is near real time, or it is streaming. And then the moment you jump from batch and real time into streaming, the whole data model change actually. Because when you have a batch or near real time, you have a time span where you can do transformations. And when you do streaming, then you don't have a time to do transformation. The whole technology changes, right? Along with this one, right, another factor comes in as we have moved onto the cloud, right? Processing and compute cost. The moment you jump from batch into the streaming world, your cost will shoot like anything. And cost again goes towards ROI mapping, like how much you're going to invest, how much you're going to take. So can you share your thoughts on how, whenever a new request comes, how to talk to business? Like what are the ways? Is it important words to talk to business and go up to the level of, hey, the moment you're going to get the data, what is the actual use? What is the value add you're going to get coming out of from batch or real time versus stream? Please.
Yeah, very, very fair point. I think every use case that you need to build, and that is true for data integration use cases and other use cases, every use case you build needs to answer a business need and a valid business case. So actually, it is key that you have some business case framework that says, okay, I'm automating this because it provides value, and this is the value it provides. Sometimes it might be a data flow that we run once per month, and that is there is no clear business case to it, but you need to do it because for compliance reasons, for example. So in that case, you still need to build it, and it will cost you, and it will cost you maybe to run because there are some huge volumes, and it will cost you to build, and it is only being run 1 month, so once per month. So you might be tempted to say, no, I don't do this because there is no valid business case. But as there are compliance risk behind it, it can be invoices, it can be some declaration to a tax administration. It is still something that you will need to do. So there are things that you are obliged to do. And then on classic integrations, it's important to start with an assessment of the use case and say, okay, what is the business value it provides? And if you are having a lot of use cases, you should be asking your business to do some kind of prioritization to say, okay, this is in terms of business value, this is A, this is B, this is C, to have a sense of what comes first and what comes next. And then you need to have an idea. Sometimes it is not easy to assess with a clear or with a very detailed and very precise numbers, but to have an idea about your TCO, your total cost of ownership of the platform and of the data flows. The total cost of ownership is comprised of multiple costs. It is the cost of the platform that you are using. It can be a SaaS platform, and then it is easier to compute because you just have the number or the invoice that you are paying to your SaaS provider. There are tools like Make.com, for example, or like Delboomi that runs fully in a SaaS mode. And then you have also solutions that you might be buying a license and deploying in your own cloud. It can be a solution like Talent, for example. And in this case, you are paying a license. So in your total cost of ownership, there is what you pay for license, but also there is what you pay for hosting and for the computing power you are consuming. And then you have also the cost of the team who is building it, meaning that there is also a cost associated to it. And you need to have a view on how much all this setup is costing you in order to build a first business case on putting the platform. Once you have the platform and you are adding a new data flow, it's important to note if that data flow changes radically your TCO. For example, is it too complex to build? Is this set of data flows will take like 6 months to build? Then, of course, you need to make that assessment. Or this data flow is going to multiply by 4 the computing power that I'm consuming. And in that case as well, it's important that you do your assessment to know what is the cost and compare that to the business value. However, I'm not in favor of assessing every small business need when it does not have such impacts, meaning that the assessment also takes time. You will take time, you will spend time just to do that assessment, and sometimes it's not worth it. If it is a classic integration between, for example, you have already an integration between, I take the example of an ERP and CRM, and you are just adding one integration. Or sometimes it's a no-brainer. You have the connectors, your team has the knowledge to do it, and then you can just go ahead and build it without adding that complexity in the process. So I'm in favor of this pragmatic approach, along with keeping track of the numbers.
Yeah. So I have hundreds of questions, always. So let's also touch base integration from internal versus external sources, right? So internal normally is a bit easier, but if you instead of a company, if you're an organization where you have more than one LOBs, one OPUs, one entity in it, then, and especially across borders, so data sovereignty come into picture. That is also internal and for external as well. Second would be when you talk to the external data sources, contractual obligations also come into it, right? So this is internal versus external. And the third one I would like to touch base on virtualization. How important is virtualization within a solution where you don't have to move the data? But the thing is, the moment you don't move the data, you have to transform on the fly. So I'll give you one by one. Internal first, where across internally you can simply connect, but data sovereignty comes within the organization actually, but across the border. Yeah, please.
Yeah, clear. So on the internal integration, I think there are still, even in the internal, there are still some considerations when you are moving, because internal sometimes can be external. Like, how do you call an integration with a SaaS solution that you do not own, but they are only using? Is it internal or external? It is part of your information system, but it is still a system that is managed by a third party. So I think there are considerations when you are moving personal data or when you are moving sensitive data for your business. Data has and should has a classification, meaning that the level of the data you are moving with your data flow can be just public information, but can also be some critical data or business sensitive data. And in that case, you must be asking the question, the system I am pushing that data to, is it as secure as the source? And sometimes it is not. Sometimes you are opening, you are, for example, having information in your ERP. Your ERP is only accessible to 5% of the organization. And then you are pushing that data to a BI system that all the company has access to. So you might be breaching actually secret data or confidential data even when you are doing internal integration. If you are pushing personal data and you are relying a lot in your information system on SaaS tools, you might be, for example, in breach of certain rules. If, for example, you are sending some customer data and that customer data is moving from geographies like it is in Europe and you are moving it to the US or vice versa, and that your customers requested that their data stay in a given data location, then you are still within your internal information system and need to tackle these questions. When we look into external integration, I think we look into issues, as you mentioned, related to data sovereignty. Is the data I am sharing is data I can share externally? Do I have any contractual clauses that I should be looking at before doing that data exchange? And of course, there are security patterns that should apply. And from these security patterns, of course, you need to be encrypting everything that you are sending, and that's apply as well for internal. Today, you can encrypt very easily if you are doing integration with HTTPS using TLS 1.2, 1.3, and you can add additional security layers to that, like mutual SSL when you are connecting to systems, external one and internal one, by having the certificate on both systems and having that dual handshake being done before sending the data. So there are mechanisms that help secure that, encrypting your data, and of course, you need to assess your data flow upfront on the data classification. What is the classification of data we are looking at transferring, and any related contractual engagements you might be having with your customers, suppliers, or even if it is personal data of your internal employees.
Yeah. So before jump into virtualization, right, I want a pause here, right? I do need to have a dedicated session with you on cybersecurity. We plan to bring cybersecurity into this session, but this session itself is a huge one, so we thought we'll make it separately. We will have a separate session on cybersecurity. So before we jump onto virtualization, on this external, right, I want to highlight one more thing. As you are a CIO, you are C-level, right? When you integrate with external system have a lot of policies, right? Hey, you can only view my data sometimes. Secondly, hey, you can get my data, but you cannot transform. Hey, you can bring my data, you can transform it, but you can keep it for certain time, right? And the moment the contract with my portal is done, you must delete everything. There are multiple kind of contractual obligation with the source system. Normally we call it DAS, data as a service, right? So how do you see when you integrate and get data from someone, or maybe if your company is pushing it outside, how do you deal with these ones?
Yeah. I think the first thing is that we look into providing patterns where the customers comes and fetch the data they need. We will try to avoid patterns where we go and call directly the customer system. Many customers today are reluctant to expose their APIs publicly and to expose any endpoints publicly. So it is good to have patterns that allow you to integrate with your customers in a way that it's the customer who is initiating the call from their network, and that resolves a lot of questions in the integration equation.
You mean the ideal way is they push, you don't push.
Exactly.
Awesome. This is a very good suggestion. Yeah.
Exactly. That is the ideal pattern. But
Sorry,
then it
I have
creates
one more question.
complexity.
My
Yeah.
very related question. When you say push, I'm also a fan of push. But the moment you
Yep.
say push, shall we ask them to anonymize data before they send? Because we will have a development environment, UAT environment, and then we go to productionize. Productionize, no issues. But dev and UAT, should it be source responsibility to anonymize and give it to us, or we should be doing?
So two points there. If there is customer data, you need to ask the customer to provide you the test data. It can be a baby data set that has been anonymized, or it can be dummy data that the customer is providing to you. So if it is customer data, the customer should be able to provide you that kind of data. If it is not, and you are just having data in your own environment, say it is in the production environment, and then you are also having lower environment, it can be dev, it can be pre-prod, it can be any lower environment, staging, whatever, you should be able to anonymize the data, and you should not be refreshing production to lower production system. And this is very simple because this is very understandable in the sense that non-production environment, it is very rare that they have the exact same constraints in terms of security. So the security guarantees that they provide are less than the production. Of course, the obvious one is on availability, but also on other security elements like confidentiality and integrity. But at the end of the day, on lower environment, you should not be having production data. There is one exception to that, and there has been some laws related to it, especially in Europe and what relates to GDPR. You do have the possibility to replicate the data from production to lower environment in case there is a case of troubleshooting. Like sometimes something is not working and you don't know why it is not working, and you don't know why that integration is crashing and it's throwing, I don't know, a 500x error or something else. And when you are using some baby data set, it's not reproducing it. So it can be something with the data itself. Maybe it is some encoding charset thing. Maybe it is something more tricky. And in that specific case, there is a tolerance when you are replicating that data just in the purpose of debugging and troubleshooting.
There can be another connecting question, right? So will it be a good idea to move for this testing purpose, right? To move data from production to UAT, or create a pre-prod environment inside the production network and give selected access to the selected people and do it in production?
Yeah, fair point. It will be costly, but you can. Like you can say my pre-prod is equivalent to my prod. Like my pre-prod is ISO prod on every single point. And in that case, I don't see an issue why you don't have, why you cannot copy data there. You can even consider it as a second prod, actually. Or it can be a replication environment that you have and that might even be used for production purposes. In that case, I would say it is possible that you do that, but at the same time, the cost is far from being negligible, because a development environment generally costs much less than a production environment. It's not the same sizing, it's not the same complexity of configurations. And like, for example, if you are having auto-scaling groups in production, generally in development, you just have one or two instances. So it's not the same cost and the same config. But if it is something that you can afford, or maybe there are valid business reasons that makes you need a replica of your production that is up and running on the same security pattern, then in that case, yeah, I don't see an issue on having that. Yeah.
Yeah. So actually, I'm a big fan of sandboxing.
Yeah.
So last time sandboxing concept was only in production. You remember, like 10 years back, right? Now people call R&D environment in development as a sandbox, which is, in my point of view, is not correct. R&D, sandbox is actual data. So I'm actually a big fan of sandbox, where you can park some of the environment. Okay. Yes, yes, it's correct that when we go into production, it's a static environment. Nobody can touch it. But what if we can provision as per our whole strategy? Hey, let's have a 10% buffer environment sitting somewhere for all these kind of activities, right? So data integration testing is one thing. Second thing can be, before you go into production, right? You need to have an environment where you want to release our internal business, some business IT people to test the data rather than they go into UAT. So this is just my saying. That's how I look into it. Like the idea of sandboxing, I think that has to come back, which was there like a decade back. Now it is somehow lost. It can come back, especially in the world of cloud, right? Where you can really squeeze down your, so you have the complete architecture, but on a very small scale. That will
Right.
maybe make the life much easier. Okay. Now, next item was virtualization. Virtualization
Yeah.
is also one of my favorite topic because current world is not looking into it. They just use virtualization for the sake of virtualization. But if you ask me, if I create a holistic enterprise architecture where we have OLTP system, then we have OLAP system, then we have serving layer. For me, before serving, there has to be a big China wall, which is a virtual layer. So OLTP systems and OLAP systems and big data XY, all systems should connect to that virtual layer, and then serving should connect to that. That's what my
Yeah.
thought process. I'm still unable to implement this piece because this will cost actually, right? And there has to be a valid data culture change in this. So what's your take on this one?
Right. I might be a little controversial when it comes to data virtualization. I think unless you have a mature organization end to end, not only your data department. Data virtualization needs a lot of responsibility. So just to explain things in a simple way, data virtualization, basically we have data sources, and then you build a logical layer on which you modelize your data sources, and then you can build views, and those views will go and fetch the data from the data sources, give it to you without transferring them physically into a physical data layer. So that's said simply, but when implementing it, it is extremely complex and needs a very mature organization. It needs a mature organization from data governance perspective because you should only be putting in your logical layer only what you need. If you start putting a lot of things there, you are going just to kill the performance of the system because this system works like almost 100% in memory. And if you are not optimizing your queries and only getting what you need, it can become very quickly a nightmare to maintain. The second important item is that you might still need a physical data layer. Today, the vendors of data virtualization tool will come to you with the promise that you no longer need that data warehouse or data hub or data lake or whatever name you give it, but basically that intermediary data layer where you persist your data, and they are selling it in that way. But it's important to know that at the end of the day, the computing needs to go somewhere. And what data virtualization tools are doing, they are pushing that request of computing, they are pushing it into the source system. So basically, if you are doing a query between and a join between something on your CRM and something on your ERP on a company ID, what it's going to do is that it's going to fetch the data from your CRM and going to inject that data in a query to your ERP. If that query is not on the right index, you are impacting a transactional system in production just for the sake on getting the data on a logical layer. So unless you have the means to have your systems on like great performance, I think you still need that intermediary layer. And I think it does not prevent you from having it, actually, even if vendors might say otherwise. And why I mentioned the data governance part specifically when speaking about data virtualization, even if data governance is a more global topic and it's not only relevant in this case, is that when you are working with logical data layers, the metadata is the first thing you are looking at. And when you are looking at your metadata, you need to have clear definition. So basically, you need to have your internal data dictionary or your internal data glossary internally to know exactly what data and what metadata relates to what. And know that when I'm defining a customer that gets that attribute from the ERP, that attribute from the CRM, that attribute from that marketing tool, I'm having the correct definition and I'm bringing a stamped golden record from my system. So it's a from promise perspective, I think it's a great promise. From implementation perspective, I have seen more disappointments than positive feedback when implementing data virtualization. And I think because there is a huge gap between what you are told when you are buying and what you find when doing the implementation. And it is good to lower a little bit the expectation from what you are being told and come back to basic data stuff, where the data is, where the computing is happening, and what I do need as minimum to make this work.
Actually, you're absolutely right. As I mentioned, I'm a big fan of virtualization. But again, there has to be a data culture in the organization. Organization has to be mature enough to understand the importance of metadata, right? That's we have been discussing on our Gen AI topic. So I give you, you raised a very good point, right? You have to be very particular about your compute. Somewhere, someone has to do compute in cloud.
Exactly.
Right? That is what people miss actually. I'll give you a funny story. I won't name the person, I won't name the technology, but this guy come to me, hey, Mustafa, you are using this technology. Why don't you use this technology? I won't name it, else this guy will immediately catch. So I said, okay, I can take the suggestion. Can you tell me where it will use the storage and compute? The response was, we can use anywhere. Except you cannot be anywhere. How much that will cost? When you're implementing a Gen AI solution, every token will cost you.
Right.
If you are loading data into vector, you are doing embedding, every embedding is a token, and token costs you. Writing will cost you, reading will cost you, prompting will cost you, everything will cost you. How much historical data you're throwing back into as a prompt, that will cost you. So you cannot say, hey, we can put it anywhere, Mustafa. I said, come on, guy. So that's on a lighter note. Yeah. So again, yeah, visualization.
I want to comment on that, Mustafa, quickly. I think there is a cultural and a gap from the professionals who lived through the bare metal era and the professionals who are cloud native since they started their career. So I come from a world where we needed to size every machine. I come from a world where you don't request a database. You request exactly like the size of the database, how much memory you need, why you need that specific thing. Like we lived in a time where we defined every single index, and we lived in a time where we were looking into execution plans to optimize SQL queries one by one. And we moved from that situation. And actually, when you were facing a performance issue, you cannot just say, yeah, let's take a bigger machine. That option didn't exist at that point of time, right? So we were sizing every server and sizing it like for today and for 5 years. Like we were doing the growth forecast, and we were doing like those calculations to say, okay, how to ensure high disponibility, high availability. Well, you need to put that, I don't know, the load balancer, and then how many machines do I need? And then is it active? Is it passive? Is it active? And what is like, if it is active, like what is the algorithm I am doing around Robin? I am doing something else. So we lived through that part of time. And today, when you are faced with a SQL query that is taking too much time, the first answer you are getting is, yes, let's have more capacity. And that changes a lot the way, I think that changed a lot over time, actually. But indeed, you are paying for it at the end of the day. You are paying for every piece of data that you are storing, and you are paying for every piece of data you are processing. And you need to be cautious about that, because it can make your TCO, your total cost of ownership, explode over time, and can totally make a technology irrelevant. Like if it is costing too much, you no longer have a viable business case. And if you don't have a viable business case, it is at risk that someday you are being told, well, we need to kill this because it costs us too much. And it's not like compared to the business value it provides, it is not viable economically.
Correct. Actually, I have so many examples, right? Let's discuss someday, right? One of the places, what happened, this guy come to me, Mustafa, this cost was coming $10,000 a month. Suddenly, a developer made a mistake. While implementing a code in production, he deleted something. So he said, okay, no worries. We have a backup. They recovered from the backup. The moment they recovered, it was a 10 terabyte backup. The cost shooted from 10,000 to 40,000. And it was just a small mistake. You make a mistake on-prem, no issues. You make a mistake on cloud, you pay, right?
Yeah, exactly.
Okay, let's not go into that in detail. Let's jump onto the AI. We have less. 17 to 20 minutes. I think we have set a good stage for our audience, like what is integration, how it really works, right? Let's jump onto the AI. AI is a new piece. We all know that, right? And it is very important to understand like how AI use cases work. Not everything again. Actually, most of the AI solution wants real time or streaming data. So, so how do you see the ROI and all those kind, especially when this AI thingy come, your time span is very less, and you end up get data from everywhere. You are taking from Word, you are taking from documents, you are taking from PDFs, you are taking from external social media. For me, in this integration, interoperability becomes a key where data understanding across both sides need to be there. Please.
Yeah. Yeah, I think I would split the discussion into two parts. Part is how you query your models and part on how you feed your models. And in both cases, there is a data integration use case, but these are different use cases. When we are looking into querying models and querying large language models, today you can easily build an API on top of them. Some comes already with an API that you can use for prompting. And if you look, for example, at OpenAI, you will find the full documentation there. And basically, you can even go to ChatGPT and tell them, this is the signature of my API. Write me a code, I don't know, in Python or .NET or whatever, so I can query that API. But some, as I mentioned, some data integration tools come with built-in connectors that can help you integrate directly with a model so you can query it. If I take the case of generative AI, I have seen many real-time or near real-time integrations. We didn't detail the discussion on the real-time, but it is near real-time indeed, not real-time. And what we are seeing in these cases is that these endpoints are taking too much time to respond. So it is important when you are building generative AI use cases to be mindful of the time of the answer. So little asynchronous use cases might be much better than classic real-time use cases. When you are building a chatbot and you are sending an important amount of text and you have context window that is large and the response window that is large, you can be waiting for 4, 5, 6 seconds before getting an answer. And that impacts the end user experience. So the integration pattern matters in this case. And I think when you are building application that should respond real time, you need to work on tweaking your prompts on, for example, limiting the context window or limiting the response or choosing a model that is more efficient than another model in terms of response time, even if it degrades accuracy, for example. So typically, we were in a situation where GPT 3.5 Turbo was much quicker than GPT-4, even if GPT-4 was more accurate or it has better, accuracy. But you still go with GPT 3.5. Why? Because you have that near real time and you have that performance part. As we move forward, we are seeing that the price per token is decreasing, the accuracy is increasing, and I think the real-time integration will become more and more real. But still today, it's important that you consider that in the equation. Now, coming to the feeding of the models, I will separate two cases: a case of a classic model and the case of LLMs. When you have your classic machine learning model, you might be tempted on having like an immediate feedback going to feed your model. Like you are having your model being executed, it shared the recommendation. And the user is telling you, no, this recommendation is not good. You should have shared this recommendation with me. That is a feedback. You might be tempted to re-inject that feedback immediately in your model so you improve it on the fly. This is something that works well, and it can be asynchronous. And actually do recommend asynchronous integrations when it comes to this kind of integrations. The situation becomes more tricky when we are with LLMs. LLMs are models that takes a lot of time to instruct, and it takes a lot of volume to instruct. So you cannot just send the feedback and expect that they act on that feedback. What they will do is that they will act on that feedback for a given conversation or during that session, but they cannot, like if you open a new chat, they will redo the exact same mistake. So you should be batching these integration. And I think as we move forward, we will be in ability to re-inject improvements directly real time or almost real time to an LLM. Then there is the question of training the LLM and how you are integrating and injecting that initial data set to an LLM. Here, I think the most suitable technologies are data streaming because of the volume, not because of the real-time, non-real-time topic, but related to the volume, the data streaming aspect seems the most reasonable. But the real challenge I see is how much data quality controls you put into your data integration flow so that you remove all the biases, you remove all the data of bad quality, and you only send curated data to your LLM. LLM will reproduce every issue you have on your training data set. Like that is the basic, garbage in, garbage out principle. So your data integration layer will hold the responsibility of filtering to an extent what you are injecting to your LLM. So your LLM is responding in an accurate manner and is responding with the right answer without including harmful content, without having bias integrated into it. And I think the data integration layer can play a role there. As data integration professionals, we have some dogma that says never include business rules into a data integration flow. I think when it comes to data streaming for LLMs, I believe that it's no longer business rules. It is more of a technical and management rules that can be integrated because it is so critical to the process that it becomes even like a security feature. It's like the encryption or like a simple security feature that needs to be integrated there to make that level of filtering upfront with clear rules, deterministic rules, ideally, so that you can have cleaner LLM models at the end of the day.
Yeah. So that was a complete picture. Actually, thanks for sharing that perspective. Like I think you've covered the challenges as well. Let's jump on to quickly because we have a time check, right? We have 10 minutes left. Let's quickly jump on. So quality and consistency, I think indirectly you also covered that. It is very important to have the quality and consistency. And when we come towards integration and maturity, governance has to be there, and governance make sure these things are covered. Best practices in the market. How do you see this point? And I think let's connect the last one into one conversation, last one as well. What are the future integration evolving, with the help of AI, because AI
Right.
can also help you, right? Well, you can give it to LLM, hey, this is my source, this is my target, and this is my pattern of integration. Build me something. It'll go and build it for you, right? How do you see this integration improvements happening in future with the help of AI?
Yeah, I think on the best practices, especially related to data integration and the use of data integration in AI, we touched based on some like identifying the business value. I think that over time, you will be building hundreds of data flows. And you don't want that to become a nightmare to maintain. So the maintainability of that is important. And that relates to documentation, to inventorying everything that you are doing, but also globally to make your data integration development goes in a very processized, industrialized way of doing things on how you define the need, how you template the business requirement, how you will do the development, how you will test the development, how you will put it in non-production environment, how you will move it to production environment, how you manage specific corner cases and edge cases, how you manage cases of migration, how you manage cases where you have sensitive data. So as you move forward and you build use cases, you will gain maturity. And it's important that that maturity is not just tribal knowledge. You need it to be clearly documented and clearly inventoried. When it comes to the use of data integration with AI, I think there are a couple of more best practices that you need to incorporate. One of it is ensure the security of what you are transporting, because you are generally working with, when someone is chatting with a chatbot, they think that it's like they are chatting with a friend, like they think it is a private conversation. So in that conversation, you can find many things that actually should not be stored or should not be seen by the machine. So you need to put some safeguards there to encrypt the data, to clean the data, to keep only what is required. And then in the everything related to AI, you need to get that feedback. It's important that you put some integration so you are getting a feedback that the user can tell you this is good, this is not good, this is hallucination, and so on. Coming to the last question on the how AI is impacting the data integration and what things that we can have.
Before we jump onto it,
yes,
let me set a context. Let me become a prompter. I add one more thing into it.
Yes.
So we can conclude onto this one. In the advancement world of this integration in the AI, right? Let's bring the perspective of creating models. Actually, what is model? Model is a combination of algos, right? You connect algos here and there, it become a model, and then you can have multiple models connect to each other. It's a bigger model, right? End of the day, that is what it is, right? Data scientists normally create these mathematical and statistical models. All of the world which we are saying data scientists, these are normally data science engineers who pick up the algos, join it, and create the theory, right? Now the context comes. You have LLM, everything. How many models per domain? Let's talk about per domain. Let's pick up, okay, banking domain, let's for say. In banking domain, how many models might be there? 100,000? 10,000? There will be a limit. A lakh? 100,000 models? That is what the model will be there, right? And if you go for a combination, how many combinations can be there, right? Now, you throw all those models into it. You do the proper metadata across this. You create proper ontologies and relationship on the models and algos. You do everything. And then you give it to, okay, you put it into the vectorization as the vector. You do the vector, embedding everything. And then you ask it, hey, can you create a financial risk model for you? Will these kind of advancements?
No, simple answer. I don't think so. Actually, just one thing. If you are getting, sorry for the term, but if you are getting a dump model and you are combining it with a dump model, you are getting even a dumper model. So actually, there is a complexity where you are merging accuracy. Like you need to look from things from probabilistic perspective. Like when you have a model that is at 0.4 accuracy on a given topic, and you are adding another model at 0.4 accuracy. You are not getting 0.8 accuracy, you are getting 0.16 accuracy. This makes more as a multiplication than an addition, actually. So it's important to know that when you are adding a model to another model, regardless of how you are doing that merge, because that merge is far from being something obvious to do, because they rely on different data sets, they rely on different training, but at the end of the day, you are not getting the sum of both. You are getting some other function that is much more close to a by than to a sum. So that's an important. Like if you take every single model in the world and you say I'm creating my magic new model, you are actually combining something that are good and you are also combining things that are bad. So the technology or the magic will lie on how you can get the best of every model, and that is not something that is simple. The way these models have been built is that complex, is that it's very intricate to get into. This is what they do as best. So I'm taking that part and I'm linking it to the other best part that is here. And yes, there will be a finite number of models at the end of the day. I think we are at a couple of thousands today, if we look at the serious ones. But yes, I think you should more be looking into how I'm having clean input. You should more be looking into how I reinforce the testing process so it can get feedback and the model can improve themselves, than looking at combining multiple LLMs.
Okay, good. Okay, I think before I throw more questions, we already again have a time check. We are already there. We have 2 minutes. I think let's conclude it. Again, thank you so much, Ahmed, for being part of this podcast. And this won't be the last for sure. I already have a cybersecurity topic parked with you. I have to find a time from you. And we will definitely have that session, because cybersecurity has become a bigger issue and it will grow like anything. Because as you have faster and faster technologies and cheaper technologies, people want to connect with everything. People want to connect even with their. Right now, we are not connecting with our mobiles actually. Tomorrow we will ask, right? Connect with my mobile and tell me what is there. there are terabytes of data sitting there in our cloud and in our hard disk, right? Awesome. Again, pleasure. Thank you so much, Ahmed, for taking out time for us,
Thanks.
and looking forward for the next session. Thank you so
Thank
much.
you. Thank you very much. Have a great day. Bye.
You take care. Bye-bye. Thank you, everyone, for being part of this session. Pleasure to have it. Looking forward for the next session. Take care. Bye-bye.